Can you see the material?
Yes, ma'am. Ma'am,
Hmm.
ma'am, please continue with the QS plane, the curve that we explained at
Which
last in
one?
the
Which one? Which one?
earlier, ever one.
Uh,
The QS plane, ma'am. When you were telling
US
the
plane.
yes, ma'am.
This one.
Yes, ma'am. From here only.
So we know that QS is equal to 1 plus GSHS. 1 plus GSHS is QS. So GSHS can be written as 1 plus GSHS minus 1. Okay. So if we shift this particular axis, if we give a translation at this particular point, then this QS plane will become GSHS plane. Though we don't shift this actually while plotting the GH plot, but if we give the translation, then it's clear that this one will be the minus 1 J0. This point will be the origin. So this point is called the critical point, right? And this one is QS phasor. This is tau Q. And if we plot tau GH, we'll see that the shape of the plot is exactly same as tau Q. This is 1 plus GH, that is Q phasor. This is minus 1, and hence the resultant, this one will give us the GH phasor, right? So if we plot the simply the QS plot, considering this to be the critical point, then we'll get the GH plot. So this one is the GH plot, and when we'll be considering GH plot, we'll count the encirclement of the critical point and not the origin. So this is my tau GH. Okay. Now for physical system, we'll um, verify this later on while solving some. While solving the problem that in physical system where number of zeros are less than equal to number of poles, then this part of the Nyquist contour, this infinite radius semicircular arc on the GH plane will become a real constant as r tends to infinity. And if m is less than n, then this real constant will become 0. That means the infinite radius semicircular arc will become a point which is nothing but the origin of the GH plane. And the second point that we must discuss is we know that G conjugate j omega H conjugate j omega is equal to G minus j omega H minus j omega, right? Hence, the Nyquist plot will always be symmetrical about the real axis. Number one, and from this, it's clear that if we can plot this path on the GH plane, only this part, that means S is equal to j omega, and omega is varying from 0 to plus infinity. So if we can plot this path for a given GSHs on the GH plane, then we don't have to plot this path again. We don't have to compute the mapped version of this path. Why? Because the mapped version of this path, where S is equal to again j omega, but this time omega is varying from minus infinity to 0. So this path will be, or mapped version of this path on the GH plane will be simply the mirror image of the mapped version of this path about the real axis. Why? Because we know that G conjugate j omega, H conjugate j omega is equal to G minus j omega, H minus j omega. So is it clear? You know this.
Yes, ma'am.
Okay, so let's try to solve a few problems. Now, this is our Nyquist contour. This path is basically a infinite straight line, and omega is varying from minus infinity to plus infinity, and S is equal to j omega. And this is the semicircular arc having infinite radius, and we know that if I move along this path in this particular direction, in the clockwise direction, then the A's value of S can be written as S is equal to R e to the power j theta, and in this case theta is varying from plus pi by 2 to 0 to minus pi by 2. Okay, and R is tending towards infinity. And as I said, we'll only map C11. This path can be broken into two parts. One is C11, the other one is C12. Generally, we do not denote this path as path 1. This one is path 2, and this one is path 3. So path 3, mapped version of path 3, will be simply the mirror image of the mapped version of path 1 on GH plane. So it's sufficient to map C11 only on the GH plane. The mapped version of C12 will be simply the mirror image of that of C11 about the real axis. So now the Nyquist plot, and particularly the Nyquist contour, is dependent on the type of the system. So first of all, we'll consider a type 0 system. And the open loop transfer function is given as 1 by S plus 1. Please try to follow the steps which I am showing. Okay. Now the solution is plus 1, so we'll have to plot the Nyquist, we'll have to sketch the Nyquist plot. Now, as I said, we'll denote this path where S is equal to j omega and omega is varying from 0 to infinity. একজন একজন করে ঢোকাতে গেলে কিন্তু আমি ক্লাস শেষ করতে পারবো না। বাকিদের বলে দাও একসাথে ঢুকতে, নইলে আর ঢুকতে হবে না। So this is path 1. As I said, this is path 2 and this is path 3. So we'll try to follow this convention. Now, type 0 system, it's given over here. So along path 1, see, we should not write C11 anymore. So along path 1, we know that S is equal to j omega. Omega is varying from 0 to infinity. So GHS or GSHS can be written as GH j omega. And hence, this transfer function will now become 1 by j omega plus 1. Right? S is replaced by j omega. So let us examine the two extreme points. Which are the two extreme points? When omega will be equal to 0, and the second one is when omega tending towards infinity. So g j omega h j omega, omega is equal to 0 is equal to this part will be 0 as omega is equal to 0, and hence its value will be 1, and the angle will be the angle of gh omega will be 0, because this is 0, so 1 by 1, and hence the magnitude is 1 and the angle will be 0. Remember, gh omega is a complex quantity, and hence it will have a magnitude as well as an angle. Now g j omega h j omega, when omega tends to infinity, is equal to 1 by j omega plus 1. Omega is tending towards infinity. Now since omega is tending towards infinity, hence the magnitude of g h j omega will be 0. Clear? Have you understood this?
Yes, ma'am.
But because of the presence of this j term in the denominator, right, at all the frequencies, the angle, there will be a constant angle contribution which is equal to minus pi by 2 because of the presence of this j term. So the magnitude of the phasor will be 0, whereas the angle will be minus pi by 2. So now we have drawn the Nyquist contour. We have drawn, this is our S plane, and let's draw the QS, well, GH plane. GH plane, and as we compute the values, will start plotting those values or marking those values on the GH plane. So when G j omega h j omega is 1, the value is 1, that means the frequency is 0, and we are starting from that particular point. So the point is mapped at this point on the positive real axis, right? And this axis can be labeled as u jv or real and imaginary. In some books, you will find that the axes are labeled as U and JV, and in some books, you will find that this axis has been shown as real and this axis has been labeled as imaginary. Okay, so this is the point when omega is equal to 0. So at this point, omega is equal to 0, and as omega is increasing, as omega is increasing, and when finally the omega will tend towards infinity, you see this mapped version of path 1 will terminate onto the origin of the GH plane. Right? Now this is the origin. This circle, you can see this circle. Can you see this circle?
Yes,
Yes,
ma'am.
ma'am.
The entire circle is basically the origin. Only I have blown up the origin, right? So this point is basically nothing but the origin. At this point, the magnitude is 0 and the phase angle is 0. At this point, the magnitude is 0, but the phase angle is plus pi by 2. At this point, the phase magnitude is 0, but the phase angle is minus pi by 2, right? So this is nothing but the origin, only I have blown up. This point is 0, angle 0. This is 0, angle plus pi by 2. I am moving in the counterclockwise direction. This is 0, angle plus 180 degree or plus pi. This is 0, angle plus 270 degree. And if I start moving in the clockwise direction, then this will give us 0 angle 0, 0 angle minus pi by 2, 0 angle minus pi, and 0 angle minus 3 pi by 2. Right? So when omega will tend towards infinity, path 1 will terminate onto the origin, right? So remember that when omega tends towards infinity, when the frequency value is infinity, the magnitude of this GH j omega is 0. So next is the second path, that is path 2. So path 2, along path 2, we know that S is equal to R e to the power j theta. R e to the power j theta, right? Where limit are tending towards infinity and theta is varying from plus pi by 2 to 0 to minus pi by 2. So if I put the value of R, so GHS will now become 1 by R e to the power j theta plus 1. Actually, this was S. Now S is being replaced by R e to the power j theta, where limit are tending towards infinity. Is it clear? Is this expression clear? Hello, is this expression clear?
Yes, ma'am. Yes, ma'am.
So now, since R is tending towards infinity, hence compared to this term is negligible. So this can be written as 1 by R e to the power j theta. So since R is tending towards infinity, the magnitude will be 0 and the phase angle in the denominator we are having R e to the power j theta. So the phase angle will be minus theta, right? And as we'll move along path 2 in this particular direction, theta will vary from plus pi by 2 to 0 to minus pi by 2, and hence here we'll get the phase angle like the phase angle variation will be 0 minus pi by 2 to 0 angle 0 to 0 angle plus pi by 2. Clear? So the mapped version of the infinite radius semicircular arc is basically a point on the GH plane, which is origin, right? But if you blow up the origin, then we can see how the path is, what is the locus of this path, and this is the locus, and it's moving from 0 angle minus pi by 2 to 0 angle 0 to 0 angle plus pi by 2. Okay, have you understood this?
Yes, ma'am.
So and this is my GH plane and this is the critical point minus 1 J0. And as I said that the mapped version of path 3 will be simply the mirror image of the mapped version of path 1 about this real axis, right? So this is our path 3. Okay, so this is nothing but the GH contour, and that is the Nyquist plot. This is my Nyquist plot. So this is the Nyquist contour and this is my Nyquist plot. So we have sketched the Nyquist plot. And since in the S plane, the Nyquist contour is a closed contour, so it's obvious from our previous discussion that on the GH plane also we'll get a closed contour. Okay, so you see the path 1 is starting from this particular point and the path 1 is terminating at this particular point. Okay, now the path 1 is terminating at this particular point and from that particular point the path 2 is originating, starting, because it's a closed contour. Hence, when we'll consider the mapped version, here you see the path 1 means the mapped version of path 1 has been terminated, and you see path 2 is starting from that point only. So you'll have to check that, and that is why we are getting the close contour on the GH plane as well, right? So we'll have to check whether these 2 points are same or not. If these 2 points are not same, then you will not get a close contour, and hence something is wrong. Okay. Now, what is going to be the nature of path 1? Path 1 is the most important path or mapped version of path 1. Henceforth, path 1 means the mapped version of path 1 is the most important path. Okay. So, what is going to be the nature of path 1? It could be like this also. Am I clear? Instead of being like this, it could be like this. Okay. That we don't know. Have you understood what I'm saying?
Yes, ma'am.
Okay, I'll come to that. So for path 1, take at least 5 to 6 frequency points. এছাড়া নাইকুইস্টের কিচ্ছু করার নেই, 3 মিনিটের কাজ. So you'll have to take 5 to 6 frequency points and hence try to predict the mapped version of path 1 on GH plane. Right? So the exam will have to do it, otherwise marks will be deducted. So the Nyquist plot, once again, we have drawn the Nyquist plot, and this is our critical point. So from this plot, it's clear that the tau GH or GH contour or the Nyquist plot is not enclosing the critical point, not encircling the critical point, and hence number of encirclement of the critical point by tau GH is equal to 0. That means n is equal to 0. And look at the open loop transfer function. One single pole is there at s equal to -1. No right half open loop pole. Hence, the value of p will also be equal to 0. So, in the equation, from the equation we know that p minus z is equal to n, or n is equal to p minus z. N is the number of encirclement in the counterclockwise direction of the critical point, right? So we have seen that n is equal to 0, that we have determined from the Nyquist plot itself, and from the open loop transfer function, it's clear that the value of p is equal to 0. Hence, we get z is equal to 0. What is z? Number of roots of the characteristic equation lying in the right half of the S plane. Okay. So since z is equal to 0, hence no roots of the characteristic equation will lie in the right half of the S plane, or number of roots of the characteristic equation in the right half S plane is 0, right? So what is our conclusion? The conclusion is the open loop system or open loop stable system is also stable when the feedback path is closed. That means the closed loop system is also stable. So do you have any question? Have you understood how we have drawn the Nyquist plot?
Ma'am, basically that surrounding circular path origin is of uh, plot 3, I guess.
Plot 3 means this one.
No, ma'am, the
I have not
origin one.
numbered the plots. Original.
Origin,
Nyquist contour.
origin. Huh.
You are talking about the Nyquist contour. This is the Nyquist contour.
Ma'am,
S-plane
we
contour.
have, yes, ma'am, we have, what we can say, we have just mapped the C2 on the origin side, no?
Yes. Theta will be mapped onto the origin.
And then we will take the mirror image along the real axis.
You see, in the physical
Huh.
systems, already we have claimed that in physical system where m is equal to or m less than equal to n, uh, path 2 will be mapped onto a real value if m is equal to n, and if m is less than n, then path 2 will be simply the origin of the GH plane. That we can see, yes, our claim is true because this is the origin. Okay.
Yes, ma'am. Okay.
So path 1 from this, sorry, path 2 from this equation, it's clear that the magnitude of path 2 is 0, absolutely 0.
Yes, ma'am.
So this is nothing but the origin. Only I have blown up the origin just to show the variation in phase angle. Any other doubt? Any further query? So should I close this file? Can I close this file?
Yes, ma'am.
So this is the example which we were discussing, right? And here you can see this is basically some scribbling. We have taken two different frequency points. One is 10 radian per second, and please check whether this is correct or not. This is, I guess, 0.1. You better calculate this on your own, and the angle is minus 84 degrees, something like that. And the next frequency point has been chosen to be equal to 1, right? So omega is equal to 1 radian per second. So for that, we got this value 0.5 minus 0.5 j, and hence it's clear that the path will move from this point. Path 1 will move through this fourth quadrant, 0.5 minus j 0.5, right? That's why to predict the nature of the path, you'll have to take 5 to 6 frequency points to actually predict the nature of path 1.
Yes, ma'am.
Okay. Now again we'll discuss another type 0 system. GSH is equal to, the open loop transfer function is given as s plus 2 divided by s plus 1 into s minus 1, right? So if you look at this open loop transfer function, it's clear that the open loop system is unstable. Why? Because one open loop pole is there in the right half of the S plane. Okay, so the open loop system is unstable. Open loop system is unstable. Now we'll try to find out whether what will be the stability of the absolute stability of the closed loop system when we'll close the feedback path. Again, to construct the Nyquist contour, along path 1, we know S is equal to j omega, and GH j omega will be equal to j omega plus 2 by j omega plus 1 into j omega minus 1. Right? Now again, first we'll try to find out two extreme points. So H j omega, when omega is equal to 0, so this value will be 0, this one will be 0, this one will be 0. Hence the magnitude will be 2 divided by 1 into minus 1, that is minus 2. So this can be written as 2 angle 180 degree plus 2 angle 180 degree. Yes or no? Yes or no?
Yes, ma'am.
Now this is our GH plane. This is imaginary, this is real. That was simply scribbling, so I didn't level the axis. You should always level the axis. So real and imaginary, and hence the point minus 2 will be located somewhere on the negative real axis. This is our minus 2, this particular point when omega is equal to 0. Okay. Now, obviously, since this is minus 2, hence the critical point minus 1 plus j0 will be somewhere over here on the negative real axis. Okay. Now, limit gh j omega as omega tends to infinity. So, j omega plus 2, j omega plus 1, j omega minus 1. Since omega is tending towards infinity, so this one is negligible with respect to this one. This one is negligible with respect to this one. This one is negligible with respect to this one. So we are left with j omega divided by j omega into j omega. 1 j omega will cancel out. As omega is tending towards infinity, the magnitude of gh j omega will be 0. And because of the presence of this j term in the denominator, the angle contribution will be minus pi by 2. So if you take 5 to 6 points, frequency points, then you will find that path 1 is, the nature of the path 1 is like this, and the GH phasor along path 1 is moving in this particular direction. Here omega is equal to 0, and as omega is increasing, the GH phasor is moving like this, and when omega value is infinity, the magnitude of GH phasor is 0, but the angle is minus pi by 2. We know that this is, again we have blown up the origin, and this is 0 angle minus pi by 2. Clear? Now along path 2, we know that S is equal to r e to the power j theta. So along path 2, we'll have to write over here, along path 2, S is equal to r e to the power j theta, limit r tending towards infinity, and theta is varying from plus pi by 2 to minus pi by 2. Anyway, so GSHS is equal to limit r tending towards infinity, S is being replaced by r e to the power j theta plus 2. So this is the numerator, and in the denominator we are getting two factors. One is r e to the power j theta plus 1, the second one is r e to the power j theta minus 1, right? And since r is tending towards infinity, so this is negligible, this is negligible, this is negligible. So we are left with r e to the power j theta by r e to the power j theta into r e to the power j theta. That means 1 by r e to the power j theta. Okay. So since r is tending towards infinity, again the infinite radius semicircular arc will be converted into a point which is nothing but the origin of the GH plane, and because of this the angle is theta, and since we know that the theta value is varying from plus pi by 2 to 0 to minus pi by 2, hence just assume, please bear with me, this is angle, this is angle. So the change in angle will be 0 angle minus pi by 2 to 0 angle 0 to 0 angle plus pi by 2. So this is 0 angle minus pi by 2, and again we can verify that path 1 terminated at this point 0 angle minus pi by 2, and path 2 is starting from that particular point only, and that's why we are getting a close contour. So this is 0 angle minus pi by 2, and this is 0 angle 0, this is 0 angle plus pi by 2, and the path 3 will be simply a mirror image of path 1. One arrow direction should be put on this, one arrow direction should be put in this particular direction, like this. Okay, so this is my Nyquist plot. This is my Nyquist plot. So we have sketched the complete Nyquist plot. So now from this Nyquist plot, it's clear that this Nyquist plot or GH contour is encircling or enclosing the critical point -1 J0 once in the counterclockwise direction. Once in the counterclockwise direction, clear?
Yes, ma'am.
Okay,
Yes, ma'am.
that means the value of n, number of encirclement of the critical point by tau gh in counterclockwise direction, that is n is equal to 1. The value of n will be equal to
Yes, ma'am.
1.
Yes.
And from the transfer function, you see, there is one pole of the open loop system which is lying in the right half of the S-plane. So the value of P will be equal to 1. P will be equal to 1. Ignore all these scribblings. This time
Yes,
I'm not going to explain what is n0, what is the difference between n0 and n minus 1. Okay, as we don't have the time. So the counterclockwise encirclement of it will not be origin, it will be
Critical.
critical point. দেখাচ্ছে না কেন? দেখানোর তো কথা। Yes, -1 J0. So the counterclockwise encirclement of the critical point -1 J0 is equal to 1. And from the open loop transfer function, it's clear that the value of P is equal to 1. So in the equation, n is equal to P minus Z, n is equal to 1, P is equal to 1, hence the value of Z will be equal to 0, right? So the closed loop system will have no closed loop pole in the right half of the S-plane, or the characteristic equation will have no roots in the right half of the S-plane. That means the closed loop system is stable. So with the help of feedback, it's possible to make an open loop unstable system to be stable when the feedback path is closed. The system, open loop system, was unstable, but the closed loop system is stable. Okay? Have you understood these two problems? How we have solved the problems? How we have sketched the Nyquist plot?
Yes, ma'am.
Now, let's come to type 1 system. Okay. Now, type 1 system, let me find out the transfer function. Yes, this is the transfer function. Suppose GSHS is equal to K by S into S plus 1, S plus A. And K is variable, and we know that the value of K will be positive. We have not considered negative values of K. Okay. And A is also positive, right? That means two roots of the open loop systems are at S equal to 0 and S equal to minus A, right? This is a second order system and type 1 system. Now for this particular system, can we take this contour to be a Nyquist contour?
No, ma'am.
Hmm?
J omega equal to plus minus 1 or line.
The sound is not clear. Please repeat.
The poles of the GSHs should not lie on the contour.
Boundary of the contour.
Yes,
Are,
ma'am. Yes.
are the two poles lying on the on the boundary of this contour?
Yes, ma'am. The origin one.
Only the origin one, right? So if we take this closed contour to be a Nyquist contour, then for type 1 system, type 2 system, type 1 system onwards, we'll find that the contour will pass through a singular point of the given GSHS. Hence, this particular contour is a valid Nyquist contour only for type 0 system. So for type 1 system, what can be done? Since there is an open loop pole at s equal to 0, so we'll try to just bypass that particular point. That means the origin of the S plane with the help of this small indentation. Can you see the small indentation? This one? Hello, can you see the small indentation?
Yes, ma'am.
So with the help of the small, very, very small indentation, we'll just bypass this point. So similarly, if we have complex conjugate pairs on the imaginary axis, then accordingly we'll have to go by this for selecting an acceptable Nyquist contour. Now, since in this particular case, the pole is one single pole is there at the origin of the S plane, hence we are taking this contour to be the Nyquist contour. So with the help of this small indentation, we are just bypassing the origin of the S-plane, and hence this closed contour can be regarded as a valid Nyquist contour for this particular system. Clear?
Yes, ma'am.
আচ্ছা, এগুলো তো আমি চক অ্যান্ড বোর্ডে করাই, এখানে স্ক্রিবলিং এ মানে আমি একটু বলে দিচ্ছি, প্লিজ ফলো আ কনভেনশন ওয়্যার will always label this path as path 1. We should maintain that particular convention. This one is path 2, this one should be labeled as path 2, this one will be labeled as path 3, and this one as path 4. যদিও এটাকে path 1 এটাকে path 2 বললে কিছু এসে যায় না, but still we should follow that particular convention, and when omega is varying from 0 plus to infinity, that particular path should be labeled as path 1. Anyway, since I have not followed that particular convention while solving this problem, so just I am showing along path 1, the small indentation, along the small indentation, S is varying as, or S can be represented as epsilon e to the power j theta, where epsilon is tending towards 0. This is infinitesimally small. So epsilon e to the power j theta, and this time you see we are moving in the clockwise direction, right? So this time the theta is varying from minus pi by 2 to 0 to plus pi by 2. So theta is varying from minus pi by 2 to 0 to plus pi by 2. Is it clear?
Yes, ma'am.
So along path 1, since I have labeled this path as path 1, so along path 1, GSHS will be equal to limit epsilon tending towards 0, k by epsilon e to the power j theta, that is S, into S plus A, that is epsilon e to the power j theta plus A. Now, since epsilon is tending towards 0, hence this term is negligible compared to this term, right? So we get this is equal to limit epsilon tending towards 0, k by epsilon e to the power j theta into A. Now, since epsilon is tending towards 0, hence the magnitude, now the magnitude of GHS will be infinite, and its phase angle will be minus theta. Now theta along this path, theta is varying from minus pi by 2 to 0 to plus pi by 2. So that means we'll get infinity plus pi by 2. That means minus of minus pi by 2. That is plus pi by 2 to infinity 0, infinity angle 0 to infinity angle plus pi by 2. Clear? So this path have been mapped onto the GH plane, infinity angle plus pi by 2 to infinity angle minus pi by, sorry, infinity angle 0 to infinity angle minus pi by 2. So what is the net change in angle? The net change in angle is 180 degree. 180 degree. So this small indentation on this S plane is being converted into a semicircular arc on the GH plane with infinite radius. So it's written over here, it's mapped as a semicircle of infinite radius in the GH plane. So have you understood this?
Yes,
No,
ma'am.
but
So the
ma'am,
thing is, interesting thing is, this infinite radius semicircular arc is becoming a point which is basically the origin of the GH plane, whereas this small indentation, very small indentation, is now becoming a semicircular arc on the GH plane with infinite radius. Yes, any question? Do you have any doubt?
no, ma'am, no, ma'am.
We'll have to move first. So along path 2, that means along this path, really the problems have not been solved systematically. So first of all, we'll find out the two extreme points as we have done for type 0 system. So GH J omega along path 2, that means this path. Omega is varying from 0 plus to infinity and S is equal to J omega. So at omega is equal to GH J omega, when omega is equal to 0, will be, this is my transfer function. So omega is tending towards 0. Hence, what will be the magnitude of GH phasor? Omega is 0, the magnitude will be infinite, right? And the phase angle, because of this S term, the phase angle will be minus pi by 2. S term is in the denominator. So when omega is equal to 0, the GH phasor will be represented by infinity angle minus 90 degree, right? And we can check that path 1 exactly terminated at that particular point, infinity minus pi by 2, and from that point only path 2 is originating. Hence we are getting a closed contour. And at the other extreme point, when omega is equal to infinity, you see GH J omega will be, again in this case, as omega is tending towards infinity, so this will be GH J omega, that is K J omega into J omega. As this term, since omega is tending towards infinity, so this term is negligible with respect to this. So K by J omega into J omega. So we are getting two J's, but omega is tending towards infinity. Hence the magnitude of GH J omega will certainly be 0, whereas the phase angle will be equal to minus 180 degree. So at omega is equal to infinity, GH j omega will be 0 angle minus 180 degree. Is it okay? Have you understood this?
Yes, ma'am.
Okay. So please note it down that when omega value is 0, type 1 system, type 2 system, type 1 system onwards. Okay. When omega value is equal to 0, the magnitude of GH phasor will be infinite. And when the omega value is infinite, the magnitude of GH phasor will be 0. Okay. And in case of type 1 system, sorry, type 0 system, when omega is equal to 0, we'll get a constant value, some constant value on the real axis. In this case, it is -2. In the previous case, it was 1, I guess. But type 1 system onwards, omega value equal to 0 means infinite magnitude of GH omega to be infinity, and when omega will tend towards infinity, the magnitude of GH will converge to 0. Now, we want to find out whether the mapped version of this path actually intersects the negative real axis or not. That is very important. And that's why it's better to label it as path 1, path 2, path 3, path 4. So it's really important whether this particular path actually intersects the negative real axis or not. So to find it out, now we have expressed GH j omega as a real part minus an imaginary part. Please check the expressions. Okay. So the real part is this and the imaginary part is this. So if the mapped version of that path intersects the negative real axis, so at that particular point, at the point of intersection, this imaginary path will be 0 since the point is lying on the negative real axis. Do you get my point? Do you get my point?
Yes, ma'am.
Yes, ma'am.
So whether the path is actually intersecting the negative real axis or not, for that we equate this to 0 and we try to find out for which frequency value that particular equation will be satisfied. At which particular frequency the path will intersect the negative real axis. So from this particular expression, it's clear that this equation is satisfied only when for a value of omega which is equal to infinity. Isn't it? ঠিক আছে? Now, we know that when the value of the frequency will tend towards infinity, okay, the GH phasor will converge to the origin of the GH plane. Origin of the GH plane. Hence, this is the mapped version of this particular path. So the path will only intersect the negative real axis at a point which is nothing but the origin. Have you understood this? Yes or no? No response, please.
Ma'am, can you please explain this mapping?
Have you understood this one? We have expressed GH, J omega as real plus real part plus imaginary part.
Yes, ma'am.
So we get this expression. I don't know whether the expression is correct or not. That we'll have to check, right? So if the path intersects the negative real axis, if the path intersects the negative real axis, then this imaginary path will be 0 as the intersection point is lying on the negative real axis. So it will be something like minus sigma 1 plus j0.
Yes, ma'am.
Okay. So if I equate this to 0, so from this equation, we can find out the frequency, the value of frequency at which the path is intersecting the negative real axis. Now you see this equation is only satisfied for a value of omega which is equal to infinity. Do you agree?
Yes, ma'am.
The left hand side will only be 0 when omega is equal to infinity, right? So that means when the frequency value omega will be infinity, the path will intersect the negative real axis. Is it clear?
Yes, ma'am.
So now we know that if the frequency value is tending towards infinity, then the GH plot will converge onto the origin of the GH plane that we have already seen. This one I've already explained. If the omega value is 0, the magnitude of GH phasor will be infinite. And if the omega value tends towards infinity, the magnitude of GH phasor will be 0. Okay, so since we find that when the frequency value is infinity, then only the path is intersecting the negative real axis. Hence, we can conclude that the negative real axis is being intersected by the path only at the origin. Only at the origin, and this is the origin. Now, is it clear?
Yes, ma'am.
Okay, so again, if you take a few points, few frequency points, then you will find that this is the nature of the plot. So now we are left with path 2, that is this path. So along path 2 or 3, whatever. So in this case, along path 3, this should be GSHS, not GJ omega, HJ omega. Okay, please correct this. GSHS is equal to K by R e to the power j theta into R e to the power j theta plus A. Okay, and we know that limit R is tending towards infinity and theta is varying from plus pi by 2 to minus pi by 2. So since R is tending towards infinity, so this term will be negligible with respect to this one. So since R is tending towards infinity, the magnitude of GHS will be 0, but now the phase angle will be minus 2 theta, theta and theta, so minus 2 theta. The phase angle is minus 2 theta. So the phase angle will vary in this manner, 0 angle minus 180 degree to 0 angle plus 180 degree. Actually 0 angle minus 180 degree to 0 angle 0 to to 0 angle plus 180 degree, right? And the previous path was ended at this particular point, 0 angle minus 180 degree. And this path is starting from that particular point only, that is 0 minus 180 degree. So what is the net change in phase angle? The net change in phase angle is plus 180 degree minus 180 degree, that is 360 degree. Right? So if I blow up the origin, then this point is representing 0 angle minus 180 degree. This is 0 angle 0, and this is 0 angle plus 180 degree. So this is basically a circle, though this is the origin, and we are blowing up the origin, and actually this particular path is moving like this, from 0 angle minus 180 degree to 0 angle 0 to 0 angle plus 180 degree. One arrow should be put over here in this direction. So it's basically a circle. Why? Because the net change in phase angle is equal to 360 degree. And the last one will be, so this origin is the mapped version of this semicircular arc, and path 4 will be mirror image of path 2 about the negative real axis. So this is the Nyquist plot, rough sketch of the Nyquist plot. And from this, you see, since this is the origin, hence we see that the critical point minus 1 J0 lying somewhere on the negative real axis is not being enclosed by this JH contour or Nyquist plot, right? And since A is positive, that means no open loop pole is there in the right half of the S-plane. One open loop pole is there on the imaginary axis, but no open loop pole is there in the right half of the S-plane. Hence, P is equal to 0 as well as N is equal to 0. So from the equation N is equal to P minus Z, we find that Z is equal to 0. So what about the absolute stability of the system? The open loop stable system is also stable in closed loop. Though I have written the open loop stable system, but actually you see, since there is a pole, open loop pole on the imaginary axis, hence the open loop system is not absolutely stable, it's limitedly stable. So the limitedly stable open loop system is stable when the feedback path is closed. Clear? Have you understood this? How we have solved this particular problem?
Yes, ma'am.
Now type 2 system. So type 2 system GSH is K by S square. This is the open loop transfer function, S square TS plus 1 T is positive. So for this type 2 system, since two poles are there at the origin, so we can take the previous contour to be the Nyquist contour in this case also. So the origin will be bypassed by the small indentation, and by this time we know that along this path the value of S is equal to epsilon e to the power j theta, where theta is varying from minus pi by 2 to 0 to plus pi by 2. So along this path, GSHS is equal to S epsilon e to the power j theta, and epsilon is tending towards 0, as it's a very small indentation. Can you see this? Is it legible?
Yes, ma'am. Yes, ma'am.
So limit epsilon tending towards 0, k by epsilon square e to the power j2 theta, because of this square term, t e to the power j theta plus 1. Okay. Now since it ভুল আছে, epsilon e to the power হবে, হ্যাঁ?
Yes, ma'am.
This one epsilon e to the power. Now since epsilon is tending towards 0, hence this term is negligible compared to this one. So we are left with limit epsilon tending towards 0, k by epsilon squared e to the power j2 theta. So since epsilon is tending towards 0, hence the magnitude of GH phasor will be infinite, and its phase angle will be given by -2 theta. -2 theta. So this is the uh, phase angle will change like this. The magnitude is infinite. The phase angle will be -2 into minus pi by 2. That means plus 180 degree to infinity angle 0 to infinity angle minus 180 degree. Clear? So this part can be done just mechanically. So what is the net change in angle? The net change in angle is 180 minus 180 degree. That means that is equal to 360 degree. So this small indentation on this S plane will become a circle on the GH plane. Again, this two axes should be duly leveled. This one should be leveled as U, and this one JV, or real and imaginary, right? So I preferred the second convention. This axis should be leveled as real, and this one should be leveled as imaginary. Okay. Now, so you see on the GH plane, the small indentation is now becoming a circle with infinite radius. So we start from this point, that is infinity, infinity angle 0, infinity angle plus 90, infinity angle plus 180 degrees. So we are starting from this point and we are moving in this direction. So infinity angle 0, then infinity angle minus pi by 2, then infinity angle this point minus 180 degree. Clear?
Yes, ma'am.
So at this point, the phasor length is infinite. Now, along path 2, that means this path, which is the most important path. So G j omega H j omega is S equal to j omega. So G j omega H j omega, when omega is equal to 0, will be k by minus omega square j omega 2 omega t plus 1. Now this term will become 0, right? And because of the presence of two j term, j omega into j omega, so the phasor length as omega is 0, so the phasor length will be infinity, and the phase angle will be equal to minus 180 degree, as two j terms are there in the denominator, right? So the phasor length will be infinity and phase angle will be minus 180 degree. Minus 180 degree. So we have seen that this path has ended at this point, which is infinity minus angle minus 180 degree, and the next path is starting from that very point, that is infinity minus 180 degree. Now the other extreme point, when omega is tending towards infinity, G j omega H j omega, so because of this two j terms, we'll get an angle which is minus 180 degree. Now this one will become, this is infinite as s is tending towards infinity, hence this is negligible. So we are getting three actually j terms. So the angle contribution will be minus 270 degree, minus 90 degree, minus 90 degree, minus 90 degree. So minus 270 degree, but since omega is tending towards infinity, hence the magnitude of the phasor will be 0. So again, we repeat that when the magnitude for type 1 system onwards, when the frequency is 0, the magnitude of GH phasor will be infinite, and when the frequency will approach infinity, the magnitude of the phasor, GH phasor, will be 0. So have you understood why this angle is now minus 270 degree?
Yes, ma'am.
So this point 0 minus 270 degree. Again, I have blown up the origin. So this is 0 angle 0. This is 0 angle minus 90 degree. Somewhere over here, this is 0 angle minus 180 degree. And at this point, we'll get, this is the point which is 0 angle minus 270 degree. Here.
Ma'am, please repeat it again. How it is changing from minus 80 to minus 270?
This is my origin. This is my origin, blown up origin. Clear? So this point is 0 angle 0. Now if I start moving in the clockwise direction, this point will be 0 angle minus 90 degree. This point will be 0 angle minus 180 degree. And this point will be 0 angle minus 270 degree.
Yes, ma'am.
Right? So when omega is tending towards infinity, we are this point is mapped on the GH plane as this point. That is, the phasor length is 0, but the phase angle is minus 270 degree. That means this particular path, this particular path was started from this point. That is this point or this point. 0 angle minus 180 degree, which is somewhere over here below the negative real axis. 0 angle minus 180 degree. Sorry, infinity minus 180 degree. This is infinity angle 0. This is infinity angle minus 90 degree. This is infinity angle minus 180 degree, a point just below the negative real axis. Again, if I blow up this portion, have you understood this?
Yes, ma'am.
I know it's a bit difficult. So that means the path is moving from this particular point to this particular point. This is the starting point and this is the end point. Is that clear?
Yes, ma'am.
So now, so we have mapped this path, we have mapped this path. But the point is, we'll have to find out whether the mapped version of this path intersects the negative real axis or not. And probably does. Why? Because the path is moving from this point to this point. So let's try to find out where this path actually intersects the negative real axis. Now, we can adapt this method, but there is an easier method. So g j omega h j omega is equal will be equal to k by j omega into j omega plus t j omega plus 1. That is the sinusoidal open loop transfer function. G j omega h j omega is equal to k by j omega into j omega into t j omega plus 1, right? So we do have three open loop poles. So let's try to find out the angle contribution of these poles. So because of the presence of two poles on the origin, so these two poles will contribute an angle which is minus 180 degree. Do you agree?
Yes, sir.
Hmm? Do you agree? So
Yes,
this
ma'am.
two poles will have a constant angle contribution which is minus 180 degree, and the phase angle contribution of this pole will be dependent on the frequency, and the phase angle contribution of this pole will be minus tan inverse omega t. So this is the net phase angle contribution by all the three poles. ঠিক আছে?
Yes, ma'am.
Now, if the path intersects the negative real axis at a point, then at that particular point, the phase angle at that particular point, the phase angle of GH phasor will be equal to minus 180 degree. Suppose the path intersects the negative real axis at a point whose magnitude is minus 2, whose magnitude is 2, and the point is lying on the negative real axis. That means the point is actually minus 2. That means the magnitude of GH phasor is 2, where the phase angle is minus 180 degree. So this can be written as 2 angle minus 180 degree.
Yes, ma'am.
Is it clear? So if the path intersects the negative real axis, then at that point, the net phase angle of GH phasor will be minus 180 degree, right? So the phase angle contribution of the poles when the frequency is omega is given by minus 180 degree minus tan inverse omega t, and for a particular value of omega, if the GH phasor intersects the negative real axis, then for that particular value of omega, the phase angle of GH phasor will be equal to minus 180 degree. So the left hand side is equated to minus 180 degree. Clear?
Yes, ma'am.
So from this we can find out the value of omega. This is a simpler method, right? So that means tan inverse omega t is equal to 0, or omega t is equal to 0. That means the value of omega is equal to 0.
ম্যাম অ্যাঙ্গেল কন্ট্রিবিউশনটা আরেকবার বোঝাবেন?
Angle contribution টা এই left hand side টা না right hand side টা?
রাইট হ্যান্ড সাইডটা।
Left hand side টা বুঝেছো?
ও আমি অ্যাঙ্গেল কন্ট্রিবিউশনটা ভালো বুঝতে পারলাম না ম্যাম, দুটোই ওই জায়গাটা।
This is the open loop transfer function, right? So the sinusoidal transfer function will be G j omega H j omega. We are replacing S by j omega. Hence, the open loop transfer function will be K. তুমি লেখো লেখো তোমরা। খাতা পেন আছে? হ্যালো, খাতা পেন আছে?
হ্যাঁ ম্যাম।
লেখো। So G j omega H j omega will be equal to K by j omega into j omega within bracket T j omega plus 1, bracket close. So
হ্যাঁ ম্যাম।
that will be the sinusoidal open loop transfer function, right? So in the denominator, we do have two j terms, right? So because of these two poles at the origin of the S plane, these two poles will always contribute a constant phase angles which are minus 90 degree and minus 90 degree each, whatever be the frequency. At all frequencies, the phase angle contribution of these two poles will remain fixed, and that will be minus j into j in the denominator. That means minus 180 degree. Is it clear?
হ্যাঁ ম্যাম।
So let's come to this equation. The phase angle contribution of the two poles lying on the origin of the S plane will be minus 180 degree at all frequencies. But the phase angle contribution of this third pole will be dependent upon the frequency, and this is T j omega plus 1. So the phase angle contribution of this particular pole will be equal to tan inverse omega t. And since it's a pole, so the net phase angle of phase angle contribution of the three poles will be minus 180 degree minus tan inverse omega t at a frequency omega radian per second. Is the left hand side clear?
Yes ma'am.
Now, suppose this is the mapped version of the path along which omega is s is equal to j omega, and omega is varying from 0 to minus infinity, this one, the bold one, and this is my negative real axis. Okay, so we can see that this part of the Nyquist plot, as I said, this part is the most important part of the entire Nyquist plot. So this part of the Nyquist plot is intersecting the negative real axis at this particular point. Yes or no?
Yes.
So at this particular point, you see here we have denoted the frequency omega as omega 2. So look at this again, look at this plot, part of the Nyquist plot. This part of the Nyquist plot is intersecting the negative real axis at this particular point when the frequency is omega 2. Now at this particular point, the intersecting point is lying on the negative real axis. Okay, so if this length is given by A, then this point will be denoted by minus A plus J0. Is that clear? this point is denoted by minus A, will be denoted by minus A plus J0, as
Yes.
this point is lying on the negative real axis. Hence, the critical point is represented by minus 1 plus J0. ঠিক আছে? এটুকুন বোঝা গেছে?
Yes, ma'am.
হ্যাঁ
Yes,
ম্যাম।
ma'am.
আচ্ছা, তাহলে এটাকে যদি আমরা পোলার ফর্মে এক্সপ্রেস করি তাহলে কি হবে? The magnitude will be 1 and the phase angle will be minus 180 degree. যদি কনফিউশন হয় তাহলে রেক্ট্যাঙ্গুলার টু পোলার কনভার্সন করো। So the magnitude will be 1 and the phase angle will be minus 180 degree. Have you understood this?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
Similarly, at this intersecting point, right? So we can write the coordinate of this point as A angle minus 180 degree.
ইয়েস ম্যাম।
So our conclusion is at the intersecting point, the phase angle of the GH phasor will be minus 180 degree. Now is it clear?
হ্যাঁ
Yes,
ম্যাম।
ma'am.
Again, I'm repeating, look at this point. So at this particular point, which is the intersecting point, this part of the Nyquist plot, this part of the Nyquist plot is called the polar plot. So the mapped version of this part is called polar plot. So if the part of the Nyquist plot intersects the negative real axis, intersects with the negative real axis, then at that intersecting point, the phase angle of the GH phasor will be minus 180 degree. So what we have done over here, we have computed the phase angle of GH phasor for a frequency which is given by omega. Right? Now, if for a certain value of omega, the plot, Nyquist plot, intersects with the negative real axis, then the phase angle will be minus 180 degree, as we have just seen.
ইয়েস ম্যাম।
So now we can equate this with minus 180 degree. So at the intersecting point, the phase angle of the sinusoidal open loop transfer function will be, or the phasor, GH phasor will be minus 180 degree. So from this equation, we'll try to find out the frequency at which the plot is, the Nyquist plot is intersecting the negative real axis. So from this particular equation, in this case, we see that when the omega value will be equal to 0, for omega is equal to 0 radian per second, the the Nyquist plot will intersect the negative real axis. So far, is this clear? Take your time.
Yes, ma'am.
Okay, so again, I'm repeating that for a value of omega which is equal to 0, the Nyquist plot will intersect with the negative real axis. And we know that when the value of omega is 0, the magnitude of the GH phasor is infinity. Right? So the obvious conclusion is that the Nyquist plot, or basically to be more precise, the mapped version of this path, or in other words, the polar plot, will intersect the negative real axis when the frequency value is equal to 0, and hence the intersecting point will be at infinity. Have you understood? Have you understood?
Yes, ma'am.
সবাই বুঝেছো?
Yes,
Yes,
ma'am.
ma'am.
Since omega value is 0, hence we conclude that this plot will intersect the negative real axis only at infinity. So this is the intersecting point, right? So after intersection, the path will move like this. Okay. Now, since this path is intersecting the negative real axis at infinity, that means the critical point -1 plus j0 will be somewhere over here. ঠিক আছে?
Yes, ma'am.
Now these two are basically the same points. Okay. So you see, we are left with this particular path. So along this path, GSHS is equal to, along this path, please don't write GJ omega H omega. That was a mistake. That was incorrect. So GSHS is equal to limit r tends to infinity. And this one, since r is tending towards infinity, hence this term will remain. The magnitude of the phasor will be 0, and the phase angle will change. The phase angle will be 0 angle minus 3 theta, 2 theta plus theta in the denominator. That means in the denominator we are getting 3 theta, hence the phase angle will be minus 3 theta. Now theta is varying from, in this case, from plus pi by 2 to minus pi by 2. Hence the change in phase angle will be 0 minus 270 to 0 angle 0 to 0 angle plus 270 degree. So net change in phase angle is 540 degree, isn't it?
Yes, ma'am.
That means 360 degree plus 180 degree. Now, why I have represented this origin in this form? This represents the change in phase angle, which is equal to 360 degree, and this two together basically represents one semicircular arc and represents basically the change in phase angle, which is equal to 180 degree. These two together gives us the change in phase angle, which is equal to 540 degree. Now, why am I blowing up the origin that I am not discussing in this particular class? Because the time will not permit. So this time I'm not explaining this one. Generally, I do explain why I'm blowing up the origin. Okay. So if you're interested, after your exam, Those who are interested, you can contact me and I can discuss why I'm blowing up the origin like this. Anyway, so actually this one is the origin. So this path will be will converge onto the origin, and this one will be the mirror image of this path. And already we have drawn this infinite radius circle. Okay. Now, as we have discussed, -1 J0, the critical point is somewhere over here on a negative real axis. So if I start moving along this Nyquist plot, so this is basically a point. So I'm starting like this onto the origin, then I'm moving along this path, then I'm moving along this path, right? So I'm traversing this close contour in the clockwise direction. Hence, these are the arrow directions. This path was moving from this point to this point, hence the arrow direction. At this point, the value of omega was 0. At this point, omega is increasing. So the arrow direction is put in the increasing direction of omega. So I'm moving along this close contour or GH contour on the GH plane in the clockwise direction. In the process, I find that I'm enclosing the critical point twice in the clockwise direction. Have you understood? Look, I'm moving like this. And in the process, I'm encircling the critical point, or rather, this GH contour is enclosing the critical point -1 plus J0 twice in the clockwise direction. Is it clear?
Yes, ma'am.
Hmm. Yes, আর কারকে জিজ্ঞেস করছিলে কি?
No, ma'am. Clear.
Absolutely clear. Hence, in this case, the value of n, number of encirclement of the critical point by the GH plane contour in the counterclockwise direction will be equal to -2, because we are enclosing, or GH contour is enclosing the critical point twice. But since the encirclement is in the clockwise direction, in the clockwise sense, hence the value of n will be -2. Have you understood this?
Yes, ma'am.
So the value of n is equal to -2. The value of p, that is number of open loop poles lying in the right of the S plane, is 0. Hence, in the equation, this is n is equal to p minus z. The value of n is equal to -2. Okay. 2 encirclement in the clockwise direction. The value of p is equal to 0. Hence, the value of z will be equal to 2. So, the value of z is equal to 2 since p is equal to 0. So, what does it signify? The closed loop system will have two poles, two closed loop poles on the right half of the S plane, or two roots of the characteristic equation will lie on the right half of the S plane. And hence the closed loop system is unstable. So have you understood this?
Yes, ma'am.
Absolutely clear? Do you have any question? Do you have any question?
Ma'am,
Hmm?
can we check the stability of the open loop system with the GS contour?
The
Just like
stability of the open loop system, if the open loop system is given in factored form, then simply by mere inspection you can check the stability of the open loop system.
yes,
Like this
ma'am.
one, since T is positive, so this one is stable, open loop system is stable. Whereas in this case, in the type 0 system, the second type 0 system, which we discussed, so in this case, you see one open loop pole is there in the right half of the S-plane, and hence the open loop system is unstable.
Yes, ma'am. But for the closed loop, we have to plot that GS
Nyquist
contour.
plot, yes.
Yeah. So just I was confirming that can we check with the GS contour taking origin as a critical point for the open loop system?
Yes,
Yes, ma'am.
you can. And that's the reason, that is the reason for blowing up this origin. It was that type zero, type 1 system. As I said, the net change in angle, you see, the net change in angle in this case was, I guess, 360 degrees, isn't it?
Yes, ma'am.
Has to be 360-degree, right? So that means this contour, if I consider this point to be the critical point, that means that means this origin is being encircled by this contour, sorry, in this direction. Once and is being enclosed by this in the opposite direction. So the number of encirclement will cancel out and the number of encirclement will be 0. So to find out whether this contour actually encircles the origin of the GH plane or not, that is the reason for blowing up this origin.
Yes, ma'am.
And
That was
this
the doubt.
blowing up, huh? Yes? Pardon?
Yes, ma'am. That was the doubt.
Yeah. And when it will be required if the open loop transfer function is not given in this factored form, then we'll have to that have done over here. So then we'll have to apply the Nyquist stability criterion twice. We'll have to find out the encirclement about the origin and we'll get some information from that. This N0 represents the encirclement of the origin. Okay. And if I can find out the number of encirclement of the origin, oh, generally the number of zeros present in a system is much, much less than the number of poles. So if the denominator and numerator are given in polynomial form, and if the system is a higher order system, then unless you factor the denominator, you won't be able to find out how many open loop poles are there lying in the right half of the S-plane. Am I clear? Is it clear what I'm saying?
Yes, ma'am.
If the denominator is a higher order polynomial, then unless you factorize it, then otherwise it will not be possible for you to find out the number of open loop poles lying in the right half of the S-plane. But since the order of number of zeros are pretty less than the number of open loop poles. Hence, very easily you can factorize the numerator polynomial, and from the numerator polynomial you can find out, after factorizing, if you can find out the number of open loop zeros lying in the right half of this plane. Is it clear? So now we'll find out number of zeros of open loop systems which are lying in the right half of this right half of the S plane, and we'll find out the number of encirclement of the origin by the same plot, that is n0. So in this case, you see the number of encirclement of the origin is 1 in the
Yes, ma'am. 1.
counterclockwise direction. ঠিক আছে? In the counterclockwise direction. So n0 is equal to 1. From this, it's clear that z0, now z0 is known to us. And we want to find out the number of open loop poles lying in the right half of the S plane. As the denominator, again I'm repeating, the denominator is given in the polynomial form, and the polynomial is a higher order polynomial, right? So we can find out z0. In this case, you see z0 is equal to 0, right? Again, we'll apply the same equation, but we are counting the number of encirclement of the origin, which is 1. So the equation will be P0 minus Z0. So what is P0? Number of open loop poles lying in the right half of the S plane, right? Z0 is 0. So from this, you see, if we find out that P0 is equal to 1, yes, indeed, P0 is equal to 1. So that's why I'm blowing up the origin. কিছু কি বোঝা গেল কি বলার চেষ্টা করছি?
Yes, ma'am.
Now, once we get this P0, then we'll apply the Nyquist criterion again, and now we'll count the number of encirclement of the critical point -1, that is n minus 1. Now, P's number of open loop poles is 0, is known. From this, now we'll try to find out number of roots of the characteristic equation lying in the right half of this plane. Do you have any more questions? Any more questions?
No, ma'am.
Okay, just a moment, don't leave the meeting.